Okay, this is a small tutorial to show users how to convert LAS point cloud data into raster into a raster-based DEM. So let's begin. I'm using ENVI to do this transformation. When you open ENVI, here's ENVI. You go up to File, open external file, LAS LiDAR, convert LAS data, and then you find your LAS file, Tridex. So let's just pick one, Hanksville 24 LAS, and then you want to leave it as ENVI raster file. You want the output image to be elevation and intensity. It'll be half as fast, or it'll be 2 times as fast if you choose just one of these. But just because you might use intensity and elevation, so I just leave it the same. Here's the most important part. Just leave interpolation as linear, extrapolate edge no, background value. You can set this to whatever you want. I typically just leave it as it is. So this is the most important part. Pixel size has to be large enough to encapsulate several elevation points in the LAS data to average the value. If it's too small, the pixel will, I believe, will not have any elevation information. So I typically set this to 1/2 meter, and it turns out pretty good. Output data type, if you leave it as an integer, it won't be as precise as if you did floating point. So floating point, it'll take longer, but the accuracy of this calculation will be better. So choose the place you want to put it. Give it a name. I'm just going to put it in the same folder, LAS 24.2 raster, and then you hit OK. So it'll compute statistics, and then it will build the DEM. The final image size will only be about 32 megabytes if you're using this Hanksville data. However, it takes a long time to compute, so I'm just going to go ahead and cancel this and show you what the result should look like. So when the calculation is finished, you should have a file here in ENVI. You have a DEM image and you have an intensity image. I'll go ahead and load the DEM, and that's what it looks like. So this specific tile, the elevation is fairly constant in the eastern side. So if you go to Tools, Cursor Location Value, you can actually see right here each pixel is now assigned a precise elevation for that specific pixel. You may want to test putting the pixel size at a smaller or at a higher resolution, maybe 0.25 meters per pixel, depending on your needs. I haven't tested it below a 1/2 meter, so it may work. So what you can do in ENVI is you can go to color mapping, color tables. I like to just change the color table, and you can stretch this color table to be whatever you want, and that will allow you to pull out uh, to highlight specific elevation ranges. See, you see these bushes right here? You weren't able to see those when it was fully stretched out, but once you increase the contrast, you can see much greater detail. You see that? So that's just a quick tutorial of using this DEM to get important information. So this raster it can be opened by ENVI. What we really would like to do now is convert this image into a Geotiff format, and that way we can import it into ArcGIS. You don't want to go to the display window and click File, Save Image As. This option will save the image as a TIFF. You can save it as a TIFF here. However, it's only going to save it's not going to save the elevation data associated with the DEM. It'll just save RGB values. So you don't want to do that. You want to go up to here, click File, Save File As, and go to Geotiff. You select your file. Let's just export only the DEM image, for example. So just select the DEM. You can do both. It'll give you two outputs. So just do the DEM. Hit OK. Give it a name. That looks good. And when you hit OK, it'll run. It'll give you a Geotiff that you can then easily open up in any photo editor like Photoshop, or you can open up in Illustrator, ArcMap. It should produce a TIFF image as well as a TFW file, which I believe it tags the TIFF with georeferencing information. So that's just a simple tutorial as to how to convert point cloud data into raster format.